This is Dr. Eahsan and welcoming you all to Energy Geologist Dr. Eahsan channel. So before we embark on, don't forget to like, subscribe, share the video and the channel. There's going to be a lot of exciting contents coming up exclusively on the our planet, terrestrial planets of the solar system, geology of Earth, geology of the solar system planets, and a lot of more interesting things. So, to begin, I think you can understand today's topic is going to be geology of Pluto. It's a very interesting planet, a fascinating planet, to tell you the truth. And also, it's a planet that we are always discussing whether it is actually a planet or not. Is also an important, interesting discussion nowadays that is being going on. যেটা আসলে বুঝলাম যে সো যেটা দেখতে পাচ্ছেন জিওলজি অফ প্লুটো সো 2015 সালের আগে আসলে এটা একটা ব্লারি ইমেজ ছিল হাবল টেলিস্কোপে। সো এরপরে নিউ হরাইজনস আসার পরে আমরা বেশ কিছু ব্রিলিয়ান্ট ইমেজ পেয়েছি, যেটা আসলে উইল বি লুকিং এট দ্যাট অলসো জিওলজি অ্যান্ড জিওমরফোলজি এই কারেন্ট প্রেজেন্টেশনে, and also কয়টা স্যাটেলাইট ন্যাচারাল স্যাটেলাইট আছে এবং আর কি কি প্রিমিটিভ অবজেক্টিভ দেখা যায়, এবং probably will be expecting a lot of questions from you as well. প্লুটো আসলে একটা ডোয়ার্ফ প্ল্যানেট যেটা কুইপার বেল্টে উইথ অ্যান এক্সট্রিম টিল্ট। এটার কারণে আসলে প্লুটোর দিন এবং রাত হচ্ছে এক্সট্রিমলি লং, অ্যান্ড সিজনটাও পৃথিবীর সাথে টোটালি নট কম্পারেবল অ্যাট অল, আনইউজুয়াল সিজনস। এবং প্লুটোর সারফেসটা হচ্ছে একেবারেই আইসি, মোস্টলি মিথেন অ্যান্ড নাইট্রোজেন প্রমিনেন্টলি অ্যাটমসফিয়ারে, যেটা দেখা গেছে লেটেস্ট অবজারভেশন গুলো থেকে। প্লুটোর জিওলজিক্যাল হিস্ট্রিতে যদি যাই তাহলে যেটা দেখা যায় যে এই geological process that goes on in Pluto, it normally includes movement of hot materials to the surface, যেটা আসলে কনভেকশন কারেন্টের জন্য হয়ে থাকে। আপনারা অনেকেই ভাবতে পারেন হোয়াট ইজ কনভেকশন কারেন্ট? ইটস লাইক সার্কুলেশন অফ কারেন্টস ইন দ্য ফর্ম অফ হিট, এবং এইটা আসলে সারফিসিয়াল ম্যাটেরিয়াল অর সারফেসে অর শ্যালোয়ার লেভেলে যে ম্যাটেরিয়াল গুলো থাকে এটাকে মুভ করে। সো এইটা ওয়ান অফ দ্য জিওলজিক্যাল প্রসেসেস অফ আর্থ অ্যাজ ওয়েল। প্লুটোতেও এই প্রসেসটা কাজ করে, বাট ইন এ ভেরি ডিফারেন্ট ওয়ে। তারপর হচ্ছে প্লুটোর যে মাউন্টেন ফরমেশন, আইস কাভার্ড ওয়াটার, এইটাও একটা ফর্ম ফ্রম এ সাবলিমেশন প্রসেস। অ্যানাদার থিং যেটা পসিবিলিটি প্লুটোতে দেখা যায় সেটা হচ্ছে ক্রায়ো ভলকানিজম। সো এইটাও দেখানোর চেষ্টা করব এই ভিডিওতে, এবং বেশ কিছু এভিডেন্সও পাওয়া গেছে যেটা ইনক্লুডস the presence of crack in this planet surface, and also edifices composed of methane ice cores যেটা organic compound এ। so these are all distant measurements যেটা নেওয়া হয়েছে লাস্ট 10-15 years ধরে, স্পেশালি নিউ হরাইজনস এক্সপ্লোরারটা প্লুটোর কাছাকাছি যাওয়ার পর থেকে। Pluto is 30 to 50 times further away than the Earth is from the Sun. And at that point, the Sun is still the brightest object in the sky, but it's only a point of light. So you couldn't actually resolve it. On Earth, the size is of the Sun is about the size of the Moon in terms of the angular size. You can look at them and they are, like this is how they appear in the sky, a point of light, and it is 250 times brighter than the full moon that we see in Pluto's sky. I don't know exactly what that is to look like, but it might hurt your eyes to look at. And out there, of course, it is extremely cold, minus 229 degrees Celsius being really typical. But there are a lot of variations because of this. So Pluto is extremely tilted, by the way. So not only is it itself inclined, eccentric, but Pluto itself is at a really strange angle to its orbit. So we are talking about a 25-degree, 24-degree angle, roughly, to our orbit. And the Earth's spin is something like, I can't really do that with my hands very well. Something like that on its orbit to give us the seasons. Pluto is like this. And it's doing something like this. It's doing these huge oscillations. What that means is that its summers and winters last an extremely long time. So on Earth, if you are at the South Pole or either of the poles, the daytime in the summer are 6 months long, and the nights in the winter are also 6 months long. On Pluto, that's true, but they last almost a century. So extremely long periods of day and light. And because of that really eccentric orbit, if a summer happens when Pluto is close to the Sun, so the pole pointing towards that, if that lines up, that's what we call these extreme seasons on Pluto. Pluto also has extreme seasons that happen as well as the seasons themselves when that eccentricity lines up. So then you've got an those happen every 800,000 years. There's been a large cycle there that changes the temperature of the poles dramatically as well. Because Pluto is very small, here are all the facts here. It's only 2.2% of the mass of our planet, and the surface gravity is less than 10% compared to the Earth. So you could kind of walk around. It's not too dissimilar from the moon, but it wouldn't be easy. And it's about the size of Russia or a little bit over two times the size of Australia. If you walked across Australia, you could probably walk across this. And just as a comparison in the composition, so whereas we have got a rocky, I mean an inner metallic core inside the Earth, so these two bits are metallic. The core of Pluto is actually rocky. And instead of rocky mantle, like we have. So this is where a really dense, hot, plastically deformed, substance at the mantle makes up in Pluto. Instead of that, it's got water ice acting as its mantle, and above that, it's got nitrogen. And again, I want to use the analogy of nitrogen is like the water on the earth, but it's not exactly because it's still a solid most of the time, and it's not exactly like the water that we see on our planet. But it does form this outer layer. Nitrogen is what dominates that bit, and it's also got a temperature. I mean, an atmosphere. That's something that we kind of knew from the earlier Hubble telescope observation. But it's not until we got out with New Horizons that we could actually see how complex and thick that atmosphere is. So you can see it here. You know, we have got these haze layers. So these are layers of actual haze in the atmosphere. That haze is made of organic compounds. So there's a little bit of methane on Mars as well. That's part of the atmosphere of the planet. When the solar radiation hits that methane, it reacts with itself. So that methane reacts and you form more complex organic chemicals. And as that continues, these organic compounds from the methane start to get bigger and bigger and bigger until they slowly rain out of the atmosphere. So there's a really steady accumulation of rain or haze on the surface of Pluto. You can see it again here. It's actually, kind of blue. And that's the nitrogen we're talking about. It's actually blue for the same reason that the Earth's atmosphere is blue, which is the nitrogen in the atmosphere. So, as I was saying before, this is one of the first things that really shocked the, scientists, the geologists. So this is one of the nicest pictures of Pluto. You can see an extremely diverse surface. That was one of the first things that struck the scientists working on the mission, was that it's not just some dead body. One of the first things we can see is that you have got these really cratered ancient terrains like this down here, and then you have also got these really fresh looking terrains like this. This is Sputnik Plenum just here, and then you have got kind of intermediate looking terrains, things that are a bit older but not quite ancient. So there's actually resurfacing going on in Pluto, because it's an active world, contrary to the previous belief of probably it's dead, but it actually is not. It's geologically active. Mars, for example, you can compare it with to Mars as well. Mars is pretty much an extinct world, a dead world. The surface itself isn't turning over anymore. On Pluto, it's clearly still happening. And just a reminder, there's going to be question mm, time, probably at the end of the video. So I would really encourage you guys to post questions or any inquiries related to this video. So yeah, with these organics here, we were talking about a haze in the atmosphere and that slowly accumulates. And what that means is that we have got kind of an indicator for the surface age of Pluto. So you can see these redder terrains. The more red a terrain is, the more ancient it is generally. So we have got these really ancient red terrains, fresh white surface on Sputnik Planum, and something kind of intermediate over here. This is over, I think, Tartarus dosa. So this intermediate age, a little bit red, a little bit cratered, but not quite as red as cratered as this over here. So this is our overview of the superficial process, the geomorphology of the planet. And so we have Sputnik Planum in the middle here, and this is the footprint shaped one. And Regio, Thulhu Regio here. This is one of the most ancient terms. So we found out on. So this is what we can call the encounter hemisphere. This is the bit that New Horizons got close to as it flew by the planet. So it is as it flew around the other way, we did get to see the other side, but we didn't get to see it as well. But we did see that this regio type band extends all the way around the equator of the planet. So you can imagine this thing extending all the way around. And the north polar region, we're going to start looking at. First, we're going to go over the compositions. So nitrogen, like I say, dominates the surface of Pluto. Is the most abundant chemical, and it's solid. And most of the ice that you see is in the Sputnik Planum region. So that's where you kind of want to use the analogy sometimes that nitrogen is like the water on earth. So nitrogen is kind of like the water and it flows into this plane, and so it does flow into it, and it's also the dominant gas in the atmosphere. So again, you want to use the analogy to water, but this plane, as we are going to see, isn't quite analogous to an ocean. It's very solid. It's very different to an ocean. Methane is also a feature here. That's also mostly as ice and also as a gas in the atmosphere, and maybe even sometimes as clouds. So we see some tenuous things that look like clouds here, and also in Hubble images as well. Things that kind of look like cloud that might also be, the methane, probably methane cloud. Also carbon monoxide, but that's mostly sunk into the Sputnik planum there. And water, as we know, is what the bulk of Pluto, or the bulk of the mantle of it. But that's only exposed at the equator side of the planet. This high altitude equatorial region, so that's where we get the water actually being exposed, because the nitrogen isn't actually stable there. You can see it actually. You see there's no nitrogen there. Just a little overview of some of the surface geography and the names that we have got on Pluto. So what's kind of fun about it is it's got three main things that's drawing on. It's got things that are after underworld deities. So Pluto itself, of course, is one of the Greek and Roman deities of the underworld. This is how it was named. But then we have drawn a number of other as well as fictional ones. So we have got this Regio here, the Balrog Macula as well, and then some others as well. And then the others that are named after explorers, and there's a mixture of human and robotic explorers that have been named. So we have got Viking, which was a Martian rover, Hayabusa, which is Japanese spacecraft, going to be the first asteroid. We have also got the Al Idrisi Montes here, an Arab explorer that went into Europe, so it's named after him. So now we are going to zoom in on Sputnik Planum here and see it in a little bit more details. Again, you want to call it an ocean, but it actually is not. It's solid, but it's still doing convection. It's a very strange thing. It's got these cells, so we call this cellular terrain. And so the middle bit is where the hot material now, convection, if you are not familiar with the term, is what happens in your pan when you are boiling water or when you are cooking a stew maybe, and you have got hot stuff rising up in the middle and then pushing out to the sides and then sinking down at the edges. That's exactly what we have got going on in these cells, and this is a similar process that happens on our planet as well. So we have got things push up and rise up in the middle and then sink down at these edges. So those are our convection cells, and we can see that these things are quite young because there's no craters on them. We don't see almost any craters on Sputnik Planum, so we expect that these things are surfacing pretty fast in a geological timescale, which means maybe they take 100,000 years, roughly, maybe a million years to turn over. You have also got on the edges of Sputnik Planum these mountain-sized icebergs made of water ice. So there's glaciers actually on the edges, probably because the nitrogen flows into Sputnik Planum. Glaciers form at higher altitude at this planet. They flow into Sputnik Planum, and as they do it, they break off the water ice that form the basement rock. And these things end up floating out into Sputnik Planum. You can see a little bit on the past one here. So these things like this, and these are giant icebergs, but they're the size of mountains on Earth. So these things can be sometimes up to 5 kilometers tall, pretty gigantic floating mountains. We can also see dunes on top of our convection cells, so that again is evidence that the atmosphere can become quite thick on Pluto. So that's something else to remember. The nitrogen is acting as the atmosphere. It's acting as one of the things that's moving around the surface and condenses out of the atmosphere like water does on Earth. It can condense out as an ice or it can also be a gas. And on Pluto, during these really intense summers, so much of the nitrogen is possible that it becomes a gas, that the pressure at the surface becomes way greater. So you might actually have liquid nitrogen flowing on the surface of Pluto, and wind able to actually blow grains of ice across these dunes, across these convection cells, forming these dunes. So during these intense summers, you have the pressure of the atmosphere to increase enormously, and the opposite is true during the winter. Most of the atmosphere condenses out, and you are in basically a vacuum again, and it's just kind of forming a snow. During the springtime, when the things are heating up, you have got these sublimation pit. So these things are hundreds of meters across, and the sublimation is not a process that happens much on Earth, but it's where a solid goes into a gas without going through a liquid state. Now, most of the time, we are used to seeing ice melt in spring, but in the rest of the solar system, especially where pressures are lower, like on Neptune, but Pluto and Mars as well, things go from solid to gas pretty regularly. So this is what these pits are. You have a whole piece of the ground just evaporating. And next we are going to look briefly at Tartarus dorsa here, which is what we call the bladed terrain. You can quite see the bladed texture here, but we are going to zoom in on it now. Um, so these things are ridges that you can see and can be kilometers tall, and they're basically oriented north-south, and it's called the bladed terrain. The description from some of the scientists that worked on this is that if you got all the knives in your drawer and just kind of stacked them up this way and just did it like that, so there's always alleys in between the knives, and then these just sharp clips of methane. And so this is a really bizarre terrain that doesn't really have any analogy on our planet. And the best thinking about it is that during those extreme summers and winters, the nitrogen evaporates from one of the poles. The nitrogen and the methane evaporate from the current summer pole and migrate to the colder winter pole. And while it's doing that, they're forced up the high altitude equator. So the equator is at quite a high altitude, and just like snow on Earth, if you have got moist air being forced up in mountain, you get rainfall and you also get snow coming out of the gas. Same thing happens here. As these nitrogen and methane winds blow from the summer pole to the winter pole, the methane crystallizes out and forms these massive ridges. And then the nitrogen winds are kind of blowing through the channels between these huge ridges. And it's really bizarre terrain that we don't have a huge amount of analogies for on the earth. And yes, next we are going to look at the Thulhu Regio here. So this is our most ancient terrain. So again, just that comparison, we have got almost no craters on Sputnik Planum, and then we have got this very heavily cratered Thulu Regio. Lots of craters there, which tells us that it's very old and it's been around in to experience a lot of impact. And because it's at a very high altitude, the nitrogen isn't actually stable here. So we see water ice, that bedrock exposed. Water ice is exposed there, and because it's so ancient, the water ice is then coated in what we call tholins, and those are organics that we were talking about. Those things that rain out of the atmosphere from the methane getting complex. And then once they're out of the surface, they become even more complex still by solar radiation. So you get this really on Earth. If you were to melt it, it may be look like a tar, but out there it would be like a solid substance. So we have got this really red layer of these organic compounds, and then these white bits. This is not water ice snow. Remember, obviously, this is methane snow forming on this. So it's little bit maybe like the Tartarus dorsa, where the winds kind of blow over here and precipitate out on the mountain tops. And again, just remember, if you have any observations or queries, please feel free to drop in your text in the chat box of the video. And also, you can personally let me know if you have any queries related to this. So that this crack that you can see is a sign of something like tectonism. So maybe that there's actually a liquid layer in between. Who knows? So we have that icy shell beneath water ice and nitrogen ice on the outside. But in between those two, there might be a liquid layer inside. And in fact, most of that water layer might be liquid. And so this crack, for one thing, is evidence of it because it means that it's kind of shifting around. And as that solid nitrogen and water ice layer on the outside shifts around, it might crack a bit. But the stronger evidence that we have for that is that around that crack, you see a lot more water than you do elsewhere. So it looks like some might have cryovolcanism, which is just cold volcanoes. There's this cold water being squirted out of this crack, where that liquid ocean beneath might have just pushed that water out. And part of the way that it stays that cold is all those organic compounds actually form a bit of an antifreeze in there, which unfortunately puts a bit of a damper on the idea of astrobiology. Not to say it is impossible, it's just that any organic chemistry that we know would find it very difficult to live in a liquid water ocean with that much of antifreeze kind of substances and with that chemistry. So a brief look at the moons now. So and these other little moons, we've got Styx, Nix, Kerberos, and Hydra. Now Charon itself is a really similar composition to Pluto, and it looks like it also has had a liquid layer inside at one point, but that froze over. And when it froze over, what you can see is this crack here. If you have ever tried putting a water bottle in a fridge or in a freezer, sorry, and if you screw that lid on too tight and that water can't go anywhere, the pressure can go anywhere, and it as it expands, your water bottle might crack. That's basically what happened to Charon. The whole planet basically just rifted around the middle where the water ice, the liquid ocean inside, expanded and cracked the surface. And you also have this weird layer that is Mordor macula on Charon, which seems to be some of the tholins coming. So what it might be is that between these two planets, as they're orbiting each other, Charon might be stealing some of that methane atmosphere, and there might be some of Pluto's tenuous atmosphere kind of trailing over to Charon and depositing on there. And as they deposit, they form these tholins again once that methane's on there. And then this is a final view of Pluto as New Horizons flew past around. And we've got the encounter hemisphere, just everything that we have seen so far. I forgot to mention all these guys. So these are just tiny little words and didn't really get to differentiate. They are just little clumps of ice, and so they might still argue about whether they agreed along with these other two or not. So you have a disk of ice as Pluto and Charon are forming around each other. These little moons might have formed from that disk, or they might be captures from other Kuiper belt objects. Who knows? They might also just pull them in and attracted them to it. So this is here is the other hemisphere of Pluto that we didn't get to look closely at. But what you can see is that dark equatorial band again, that Thulhu Regio. So that is where that very ancient high altitude terrain goes fully around this planet, and the new horizons, as we showed before, kept going. It would be extremely hard to stop. So once new horizons was going at these speeds to get out here to get to Pluto in a reasonable frame, it's very hard to stop. It would have to carry a lot more fuel to slow itself down. So it's just going to fly by, flew past, and then it went to this guy. So they didn't actually know exactly where they were going to go afterwards. But they knew these things were out there and figured out that they, being NASA and New Horizons team, could deflect it to one that they selected later. Now, it was originally called Ultima Thule, which was the most distant place known in Greek mythology. But unfortunately, that name is also used by the others. And the NASA scientists decided that it is not a good name to keep, so they changed it to Arrowcats, which is a probably a word from North American tribes. So it's where the original settlers in Virginia actually landed. That's one of their deities that then NASA named after. It was discovered in 2014. So yes, for one thing, it was discovered after New Horizons actually launched, and it's the most primitive object we have ever seen up close. And this is if you were to imagine what would come out of a nebula. When you see this beautiful, I should have put a picture of a nebula in here, but you see this beautiful picture of the clouds in interstellar space. If you were to take a bunch of ice and dust and just kind of push it together like a snowball, this is effectively what that would look like, a nebulous solid basically. It's never been heated. It's in the same orbit that it was in 4.5 billion years, when the solar system actually formed. It's barely moved. So if we are looking at the asteroids in the inner solar system as a counter example, they have moved around. Jupiter and Saturn moved in the orbits over time, and that kind of flung around all the similar bodies. So none of them are really what they originally formed. Everything's been mixed up. But out here, things stayed really still and quiet and stable. So this is exactly what it was. So you can see it's another kind of a double planet. What happened here is these two tiny bodies, I should say it's about 39 kilometers long, slowly orbited each other, slowly until they just bumped into each other and stuck. So there's mostly made of water and organics, similar composition to Pluto, just they didn't differentiate at all. They're just all mixed up. If you were to go there, you could grab a fistful of this, and you would have basically pristine interstellar dust. That's the stuff between the stars. When you look at the dark band of the galaxy, when you look at the Milky Way, the dark band is the dust between the stars. And you would basically be getting a sample of that in this kind of object. Isn't it cool? And as I said before, New Horizons is on the way out. I haven't added it to this one, but there's the other four probes that have done it: Voyager 1 and 2, Pioneer 10 and 11. So, New Horizons is the fifth spacecraft to achieve escape velocity from the solar system. So, it's our fifth interstellar probe, and it's on its way out, which is really very exciting. Don't know how long it will be last out there, though, actually. So, yeah. So it's fairly random scatter that I might call. The different ages, what the different amounts of cratering tells you is much more so about the freshness of the surface. So a surface that hasn't been changed at all gets a lot more craters on it. So another example, like Australia is a bit more of a cratered continent than some of the fresher, younger places. So if you were to take note on the average size of Indonesia, which is a freshly put up mountain chain, it will have a lot less craters than Australia, which is 3 billion years old, some parts of it. It's a very ancient terrain, so it's got more craters on it, and likewise here. It's a very ancient terrain, very fresh and young terrain. প্লুটোর অ্যাটমসফিয়ারে যে আলোচনাগুলো এতক্ষণ করলাম, এটা আসলে now I think it's easier for us to understand যে এটা cold temperatures mostly caused by nitrogen to not bounce out. Pluto is colder than expected for a body without an atmosphere. আর মিথেন যে হেজটা এখানে আছে এইটাও আসলে কুলিং প্রসেসটাকে ফ্যাসিলিটেট করে। প্লুটো আর ভয়েজার 1 এর যে ডিস্টেন্স এটা এখনো আননোন, বাট এটা ক্যালকুলেট করা যায়। প্লুটোর সেন্টার অফ মাস যেটা আমরা এতক্ষণ দেখালাম, and Charon, because the individual masses can be estimated by the air mass and the composition. Moment of momentum also helps determine respective masses of this planet. Pluto actually discovered করেছিল ক্লাইড টম্বাও, and উনি আসলে এটা ডিসকভার করেছিলেন through some astro photographs. So এই পুরো জিনিসটা আসলে প্লুটোর being, whether it's a planet or not, being a very distant tiny planet makes things very weirdly interesting, এবং এটার জন্যই এই রিসেন্ট স্পেসক্রাফট ফ্লাইবাই গুলা এত ক্রুশিয়াল, এবং আমাদের নিউ ইনফরমেশন পাওয়ার জন্য এতটাই এই জিনিসটা হেল্প করেছে। সো এইখান থেকে আসলে আমরা বলতে পারি যে there are a lot to learn, a lot to update in the coming days, এবং আমরা আসলে আরো অনেক ongoing study is চলছে এই মুহূর্তে। যারা অ্যাস্ট্রোজিওলজি নিয়ে কাজ করছে, আমরা কিছু কাজ করার চেষ্টা করতেছি, যদিও সেগুলো মোস্টলি অন দ্য মুন অ্যান্ড Martian geomorphology. But nevertheless, Pluto studyটাও is very very scintillating. So এই দৃষ্টিকোণ থেকে I think that there are a lot to take from this content, and I hope that আপনারা আরো আরো আগ্রহী হবেন and probably would ask a lot more questions or queries. হয়তো ভবিষ্যতে আমি আরো ভালো ভাবে কন্টেন্ট গুলো বানানোর চেষ্টা করব, প্রবাবলি এ লট মোর ইউনিক ওয়েজ। বাট এই সিরিজে আসলে আমি মার্স এবং মার্স সহ, মেইনলি মার্স সহ অন্যান্য যেগুলো রকি প্ল্যানেটস, ক্লোজার অ্যান্ড ফার্দার প্ল্যানেটস ফ্রম আওয়ার ওন প্ল্যানেট, এগুলো নিয়ে বিস্তারিত স্টাডি করার চেষ্টা করবো এবং কন্টেন্টস গুলা রেগুলারলি আপলোড করারও চেষ্টা করবো। সো উইথ দ্যাট ইন মাইন্ড, আই উড লাইক টু রিয়েলি থ্যাংক এভরিওয়ান for your patience, এবং as I said, আপনার কোনো কোশ্চেন থাকলে আমাকে জিজ্ঞেস করতে পারেন, and really thank you for your patience, and don't forget to subscribe the channel, like and also share the channel. Some pretty more interesting and exciting contents are coming up in near future. So until then, thank you everyone, and have a good day.